The Sun, Unveiling the Secrets of Our Star, Solar System explained. The Sun, a brilliant and seemingly unassuming star, is the powerhouse of our solar system. Its radiant energy sustains life on Earth, shapes planetary orbits, and influences the entire cosmic dance within our celestial neighborhood. This video delves into the intricacies of the Sun, exploring its structure, energy production, and the profound impact it has on the dynamics of the solar system. The Sun is a massive, nearly spherical ball of hot, glowing plasma composed mostly of hydrogen and helium. It has distinct layers, each with unique properties. At the Sun's core, temperatures reach an astonishing 15 million degrees Celsius, 27 million degrees Fahrenheit. In this intense environment, nuclear fusion reactions occur, converting hydrogen into helium and releasing an enormous amount of energy in the process. Surrounding the core is the radiative zone, where energy generated in the core travels outward through the slow process of radiation. Photons produced in the core bounce around, taking thousands of years to reach the next layer. Beyond the radiative zone lies the convective zone. Here, energy is transported through the movement of hot plasma, creating a bubbling and churning motion. This convective motion brings energy to the Sun's surface more quickly than radiation alone. The photosphere is the Sun's visible surface, emitting light and heat into space. This layer is marked by features like sunspots, which are temporary cool regions caused by magnetic activity. Above the photosphere are the chromosphere and corona, two outer layers of the Sun's atmosphere. The chromosphere exhibits a reddish glow during solar eclipses, while the corona, extending millions of kilometers into space, is visible during total solar eclipses. The Sun's energy is generated through a process called nuclear fusion, primarily in its core. In the core, hydrogen atoms fuse to form helium, releasing energy in the form of light and heat. This process, known as the proton-proton chain, is sustained by the Sun's immense gravitational pressure, which creates temperatures and pressures comparable to those found in the core of a star. The Sun's energy output is staggering, with an estimated 386 billion megawatts of power produced continuously. This energy radiates into space, reaching the Earth and other planets, providing the necessary conditions for life and influencing the climate and atmospheric conditions. The Sun undergoes a cyclic pattern of solar activity known as the solar cycle, roughly lasting 11 years. During periods of increased activity, sunspots, temporary cool areas caused by magnetic disturbances, appear on the Sun's surface. Solar maximum, the peak of activity, is marked by a higher number of sunspots and increased solar radiation. Solar flares and coronal mass ejections are explosive events on the Sun. Solar flares release intense bursts of energy, while CMEs expel massive amounts of solar material into space. These events can impact space weather, affecting satellites, communication systems, and even power grids on Earth. The Sun constantly emits a stream of charged particles known as the solar wind. This wind extends throughout the solar system and influences the behavior of planets, their atmospheres, and the tails of comets. The Sun, our celestial engine, continues to captivate scientists and astronomers as they uncover its mysteries. From the intricate processes occurring within its core to the dynamic and ever-changing features on its surface, the Sun is a source of fascination and inspiration. Understanding the Sun's role in the solar system not only sheds light on the fundamental processes governing our cosmic neighborhood but also underscores the interconnectedness of celestial bodies within the vastness of space. What is the structure of the Sun, and how does it generate energy? The Sun consists of several layers, including the core, radiative zone, convective zone, photosphere, chromosphere, and corona. Energy is generated through nuclear fusion in the core, where hydrogen atoms fuse to form helium, releasing light and heat in the process. What are sunspots, and how do they relate to the Sun's activity cycles? Sunspots are temporary cool areas on the Sun's surface caused by magnetic disturbances. They are associated with the solar activity cycle, which lasts approximately 11 years. During periods of increased activity, such as solar maximum, the number of sunspots is higher. What are solar flares and coronal mass ejections, and how do they impact space weather? Solar flares are intense bursts of energy on the Sun, while coronal mass ejections expel massive amounts of solar material into space. These events can impact space weather, affecting satellites, communication systems, and power grids on Earth. How does the Sun's energy influence the climate and atmospheric conditions on Earth? The Sun's energy is crucial for Earth's climate and atmospheric conditions. It warms the planet, drives weather patterns, and supports life through processes like photosynthesis. Changes in solar activity can influence Earth's climate over long periods. What is the solar wind, and how does it affect the solar system? The solar wind is a constant stream of charged particles emitted by the Sun. It extends throughout the solar system, influencing the behavior of planets, their atmospheres, and the tails of comets. The solar wind is a crucial factor in understanding the dynamics of our cosmic neighborhood. Like the video and remember to subscribe to our channel.